Welcome back. We've got a fascinating mix for this deep dive. Articles, interviews, you name it.
Company spotlights, even.
We've got excerpts from Transformer Technology magazine, got insights on cooling systems.
Oh, and some information on resilient coatings, too.
The goal, to give you a panoramic view of the trends shaping the transformer industry, from cutting-edge cooling systems
to more sustainable materials and practical tips to keep those transformers humming along.
One of the biggest trends that jumps out is the shift from mineral oil to ester fluids. This isn't just about performance.
It signals a huge change, a real commitment to safety and sustainability.
Paving the way for a greener grid for sure.
Absolutely. And to understand the why, we need to break down the advantages.
Smaller environmental impact, greater fire safety.
Exactly. And, in that interview with Anthony Coker,
Executive VP at Medel and Movolt Fluids.
Right. He mentioned esters have been around for over 40 years.
That's right. Developed to replace PCBs, so the tech itself isn't new.
But what ICE knew is the scale.
The Columbia River GSU project, for example.
They're using synthetic esters in massive transformers, replacing mineral oil completely.
Wow. So size isn't a limiting factor anymore.
Not at all. We're even seeing those large generator step-up transformers, in pumped hydro projects being retrofilled.
Like that one south of Sacramento.
That's the one.
I can see why some might hesitate to retrofill, but I'm starting to see why it's a big deal.
It all boils down to safety and economics.
Right. Remember that panel discussion? Transformers being targeted?
Alarming, wasn't it? Replacing mineral oil with esters really cuts down on fire risk.
And with supply chain issues. Retrofilling extends the life of existing transformers.
Essential, especially with those long lead times for new ones.
Coker said it best. Retrofilling is a smart way to maximize the life and value of the asset.
He also pointed out that it's a far quicker and often cheaper way to achieve risk mitigation.
Absolutely. Speaking of maximizing life, what's the biggest threat to a transformer's lifespan?
Moisture. It's the silent killer.
Moisture.
It slowly degrades that cellulose insulation, essential for longevity.
I get that moisture's bad, but how do esters combat it? What's the science?
It's fascinating. Unlike mineral oil, esters can bind with water molecules at the molecular level.
So they prevent them from
attacking the insulation.
They're actively pulling moisture away.
Exactly. It's this moisture-wicking property that mineral oil just doesn't have. Key reason why esters can extend a transformer's life.
Coker even shared an example. Synthetic esters were used to dry out wet transformers in naval dockyards in England.
Incredible, isn't it?
What about overheating? Transformers are being pushed to their limits, increasing demand, extreme weather.
Good point. Higher temperatures do accelerate aging, but if you look at that heat versus time aging curve,
esters allow for safe, short-term overloading,
giving operators more flexibility.
So wiggle room during peak demand.
Exactly. We're even seeing those new concepts like dual rating and sustainable peak load, or SPL, gaining traction.
Dual rating and sustainable peak load. Can you break those down a bit?
Sure. Dual rating means a transformer can handle two power ratings, one for normal operation and a higher one for temporary overload.
All within safe limits.
Of course. And SPL focuses on how much extra load a transformer can handle for a specific time, like during a heat wave.
Without compromising lifespan.
Precisely.
This all makes a lot of sense, especially considering the market challenges, right?
Absolutely.
Supply shortages, long lead times. What advice would you give to transformer owners who are trying to stay ahead?
Proactive asset management is more important than ever. Regular testing and analysis are crucial to prevent unplanned outages, especially when replacements are hard to come by.
In that panel discussion, Claude Bouchemin from TGH2B,
Right.
He talked about detecting early warning signs.
And educating end users about their significance, too.
Knowledge is power, especially when it comes to critical assets.
Couldn't agree more.
Don't be afraid to explore new markets, new partners.
And look into innovative solutions.
Like the ones offered by companies like Best Transformer.
Best Transformer.
They're breaking world records with their high-power transformers. Pushing the boundaries, really.
They are.
And their commitment to sustainability is inspiring. It really speaks to the broader shift happening.
Definitely. Much greater focus on environmental responsibility now. Throughout the entire life cycle of the transformer.
Absolutely. From the materials used to how they're disposed of.
It's encouraging to see the industry embracing these changes.
It really is. Now, let's get back to challenges. I want to revisit moisture. We know it's bad, but what actually happens inside the transformer when it gets in? How does it deteriorate?
Think of it like a slow sabotage mission.
Sabotage.
Moisture slowly infiltrates the cellulose insulation, breaking it down, weakening it over time.
Like rust eating away at a metal beam.
Exactly. Compromising the structural integrity.
So not a sudden failure then?
No, it's a gradual decline.
Makes sense. Early detection's crucial then.
It is. By the time you see visible damage, it's often too late.
Got it. So what are some telltale signs? What should owners be on the lookout for?
One of the most common indicators is an increase in acidity levels in the insulating oil.
Acidity.
Yeah. When moisture reacts with the oil, it creates acidic byproducts.
Ah, I see.
And those acids further degrade the cellulose insulation.
So it's a domino effect.
Exactly. One problem creates another, leading to more problems.
That's why regular oil testing is so vital.
Absolutely. It lets you spot these early warning signs before they become major issues.
I bet you've seen some pretty alarming oil samples.
Oh, you wouldn't believe some of the things I've seen. But that's why we're here.
To help us avoid those nightmare scenarios.
Precisely.
So, besides acidity, what else screams moisture problem?
Definitely keep an eye out for a decrease in the oil's dielectric strength.
Dielectric strength.
Yeah, how well the oil resists electrical breakdown.
Right.
Moisture weakens that ability, making it more susceptible to arcsing.
Leading to?
Catastrophic failures, potentially.
It's like a...
Playing Russian roulette with your transformer.
Okay, so acidity, dielectric strength. Anything else?
Visual inspections can reveal clues, too.
Clues.
Like signs of corrosion, sludge buildup inside the transformer.
Sludge?
Yeah, it's a mixture of moisture, oil degradation products, other contaminants.
Not something you want to see.
Definitely not. It means moisture has been hanging around, causing problems.
All right, so we've got acidity, dielectric strength, and visual inspections. What steps can owners take to prevent moisture from getting in the first place?
Prevention. Now we're talking. One of the most effective strategies is using a good quality desiccant breather.
Desiccant breather.
Yep. It removes moisture from the air that enters the transformer.
Like a tiny dehumidifier.
Pretty much. Simple but effective. Keeps moisture at bay.
Okay, desiccant breather, check. Anything else?
Proper sealing is crucial. All gaskets, flanges, bushings,
Need to be.
in good condition, properly sealed.
No leaks allowed.
Exactly. Even the tiniest leak can let in enough moisture over time.
Like a vampire.
Exactly. Just a pinprick can do damage.
Great analogy.
Yeah.
Any other tips?
Regular maintenance is key. Inspect the transformer regularly for any signs of moisture. Address any issues promptly.
So vigilance is key. Stay ahead of the moisture gremlins.
Couldn't have said it better myself.
All right, we've covered moisture. Let's talk overloading.
Overloading.
Literally a hot topic. Transformers aren't designed to run at max capacity all the time,
True, but sometimes it's unavoidable.
especially with increasing electricity demand. But what happens inside the transformer when it's overloaded? Technically speaking.
Think of a marathon runner sprinting the entire race. The transformer's windings heat up excessively.
Putting stress on the insulation.
Exactly. And eventually,
It breaks down, leading to failure.
like pushing a rubber band too far, it snaps.
Overloading is playing with fire. Are there early warning signs? What should owners listen for?
One of the most obvious is an increase in operating temperature.
Makes sense, but how much of an increase is too much?
It varies, depends on the design, operating conditions, but even a small rise above normal.
Could be a sign. Could be. So keep a close eye on those gauges. What else?
Listen for unusual humming or buzzing sounds.
Like when your laptop fan goes crazy.
Exactly. It's the transformer saying, hey, I'm overworked. Give me a break.
Overheating. Strange noises. Any other sneaky signs?
Watch for a voltage drop at the output terminals.
Voltage sagging.
Could mean the transformer is struggling.
Like a weightlifter lifting too much.
Exactly. Their form suffers, they can't maintain the right output.
Got it. Temperature, sound, and voltage are overload indicators. What steps can owners take to prevent overloading in the first place?
Load management is key.
Load management.
Monitor the load regularly, make adjustments, prevent it from exceeding capacity.
Balancing supply and demand.
Exactly. Like juggling, you have to keep all the balls in the air.
Good analogy. Anything else?
Cooling is crucial.
Crucial.
Make sure the transformer has good ventilation, cooling systems to dissipate heat.
Keep those fans spinning.
Exactly. A well-ventilated transformer is a happy transformer.
Load management, cooling are overload prevention strategies. Now let's talk about regular maintenance.
Maintenance. The unsung hero of transformer operation.
It's like taking your car for regular checkups. What does a typical schedule look like? Is there a standard protocol?
It varies, depends on the type of transformer operating environment, but at least once a year.
You should.
Do a visual inspection.
What are we looking for? Anything specific?
Signs of wear and tear, leaks, corrosion, loose connections, anything out of place.
So it's like a detective game.
You could say that.
Searching for clues?
Exactly.
Any other tasks on the checklist, aside from the visual inspection?
Oil sampling and analysis.
Oil testing again.
It's that important. It's the lifeblood of the transformer.
Okay, oil testing, check. What else?
The cooling system. Inspect those fans, radiators, make sure everything's working.
Right, keep those fans happy. A well-cooled transformer.
He's a happy transformer.
Exactly. Anything else, depending on the transformer's age or condition?
Well, you might need some specialized tasks, like bushing replacement, insulation testing. Best to consult with a qualified technician.
Right.
They can determine the best plan for your specific transformer.
Makes sense? Expert advice is always a good idea.
It can prevent those costly problems down the road.
We've covered a lot. Moisture, overloading, maintenance. Before we move on, I want to touch on sustainability.
Sustainability, it's everywhere these days.
It's not just a buzzword anymore. It's driving innovation.
And it's fundamental.
Eco-friendly materials, energy-efficient designs.
The industry is really making an effort to reduce its impact.
It seems like it. What are some of the key innovations? How are they making transformers more environmentally friendly?
One of the biggest is biodegradable insulating fluids, like those ester fluids we talked about.
So they're safer, more fire-resistant, and better for the environment.
They tick all the boxes. Traditional mineral oil can persist in the environment if there's a leak or spill.
But biodegradable fluids break down naturally.
Exactly. Minimizing the impact.
That's a win for the planet. What other trends are you seeing? Any other materials or processes being implemented?
There's a big push for recycled materials.
Recycled material.
In construction, like recycled steel and copper.
Giving those materials a second life.
Exactly.
Reducing the need to mine new resources.
Exactly. Which is a major contributor to environmental damage.
Fantastic. Any other innovations? Any other areas of focus?
Well, manufacturers are also focusing on the energy efficiency of the transformers themselves.
So less energy wasted means less impact.
Precisely.
It's all about reducing the footprint.
Every little bit helps.
Okay, so biodegradable fluids, recycled materials, energy efficiency, the big three.
You got it. And the innovations just keep coming. Good news for the industry and the planet.
Speaking of innovations, those high-power transformers are being used in some interesting applications. Offshore wind farms.
Green hydrogen projects.
Playing a crucial role in the clean energy transition. And as the world transitions, the demand for those high-power transformers is only going to increase.
It is.
Designing and building those massive transformers must be a huge challenge. What are the key considerations when you're dealing with that level of power?
It's like building a skyscraper.
A skyscraper.
It takes precision, expertise, attention to detail.
So what are the key considerations? What are some of the unique challenges?
One of the biggest is managing the heat from those massive currents flowing through the windings.
You talked about overheating. It's a concern with any transformer, but I imagine with these giant...
It's even more critical. Cooling systems are absolutely critical.
They need to be robust.
We need to make sure that heat can be dissipated effectively to prevent damage and maintain performance.
I bet they need some serious fans.
Oh, you bet.
What other design challenges come into play? Anything else that requires special consideration?
Insulation.
Insulation.
The materials have to withstand those incredibly high voltages without breaking down.
So they need to be strong, resilient.
Exactly. And they need to withstand extreme temperatures, environmental conditions.
That's a tall order. Finding materials that can meet all of those requirements.
It is, but the engineers who design these transformers are brilliant. They're constantly pushing the boundaries.
It really is a testament to human ingenuity. And it's inspiring to see how these transformers are playing a vital role in the clean energy transition.
Absolutely. Harnessing the power of wind, solar.
It's remarkable. Now let's look ahead. What are some key trends and challenges shaping the industry in the coming years? What are the big things on your radar?
Well, one of the biggest is the demand for digitalization and smart grid technologies.
Smart grids.
Grids that can monitor and control electricity flow in real time.
The nervous system of a modern energy infrastructure.
Exactly. And transformers are essential. They're becoming intelligent components, providing intelligence and controllability to optimize those energy flows.
So we're talking transformers that are more than just passive components. They can communicate.
Yes. They can interact with the grid, optimize energy flows, They're becoming active participants.
That opens up a world of possibilities for optimization, efficiency, reliability.
Absolutely. We can manage the grid in ways never before possible.
That's exciting. But what are some of the challenges with this shift towards digitalization? Any potential downsides?
One of the biggest is cybersecurity.
The dark side of the digital age.
As transformers become more connected, more intelligent,
They become more vulnerable.
protecting them from hackers, from malicious actors, is essential.
So cybersecurity is a top priority.
Absolutely. We're constantly working to stay ahead and ensure protection.
That's reassuring. Any other challenges on the horizon? What other obstacles might the industry face as it evolves?
Another challenge is the growing complexity of designs.
Complexity.
As we move towards more sophisticated technologies, the designs become more intricate, which makes manufacturing and maintenance more challenging.
It's a balancing act then, between innovation and practicality.
Exactly, finding solutions that are both advanced and easy to implement, easy to maintain.
Okay, so digitalization, cybersecurity, and design complexity. Those are some of the key challenges. What about opportunities? What are some exciting possibilities that you see?
One of the most exciting is the development of new materials and manufacturing processes.
New materials.
We're constantly looking for ways to improve performance, efficiency, sustainability.
We talked about sustainable materials. Any other breakthroughs on the horizon? What are you most excited about?
Researchers are exploring new materials
New material.
that are lighter, stronger, more efficient, materials that could revolutionize transformer design.
So smaller, more powerful transformers.
With a lower environmental impact. It's a win-win-win.
I like the sound of that. Any other exciting opportunities? What else are you keeping an eye on?
The development of new applications for transformers.
New applications.
They're becoming more versatile, adaptable.
We talked about offshore wind and green hydrogen. Any other emerging applications with potential?
Definitely. Electric vehicles, energy storage systems, even medical devices.
So they're becoming even more ubiquitous.
You could say that.
They're quietly powering our world in more ways than we realize.
They are the unsung heroes of the modern world.
They really are. And as the world continues to electrify, to decarbonize.
Their importance is only going to grow.
Absolutely. I think this is a good place to pause. We've covered a lot in this first part of our deep dive. The trends, the challenges, the opportunities shaping the future of transformer technology. It's clear that this is a dynamic and evolving industry.
It is. We've only just scratched the surface, but we've already uncovered some fascinating insights.
We'll pick up the conversation in the next part, delving deeper into some of these topics. We'll explore new and exciting developments that are on the horizon.
It's going to be a fascinating journey.
I can't wait to see what else we uncover.
Me too. It's fascinating, isn't it? How transformers are often taken for granted.
They really are.
These silent workhorses powering everything.
But we don't think twice. Unless the lights go out.
That's true. We expect them to just work. But there's so much engineering, so much innovation packed into these seemingly simple devices.
As we've been discussing, the industry is facing major challenges.
Oh, absolutely.
Meeting that growing demand for electricity while also reducing the environmental impact.
That balancing act is a real theme here.
It is.
It's like a high-stakes game of Jenga, trying to push the limits without toppling the whole tower.
That's a great analogy. It highlights the importance of planning, design, and maintenance. Speaking of planning, let's talk about the elephant in the room.
Yeah.
The global supply chain crisis.
Right. It's impacting everyone, and the transformer industry is no exception.
Long lead times, shipping delays, labor shortages.
It's been a perfect storm.
It really has.
Yeah.
And it makes you appreciate the complexity of global manufacturing.
It's like a giant spider web.
A spider web.
You tug on one thread, the whole thing vibrates.
And the transformer industry is particularly vulnerable, I imagine, relying on specialized suppliers for core steel, copper windings, those insulating fluids.
Absolutely.
So how are manufacturers and utilities navigating this? What are their strategies?
Well, one strategy is diversifying their suppliers.
Diversifying.
Instead of relying on just one for a critical component.
They're looking for multiple sources.
Exactly. Spreading the risk, like a diversified investment portfolio.
Ah, I see. Reduces dependence on any one supplier, makes them less vulnerable. What other strategies are they using?
Well, they're increasing inventory.
Inventory.
Instead of ordering just enough to meet immediate needs.
They're stocking up.
Building a buffer against shortages. A rainy day fund, just in case.
So you have more flexibility.
Exactly. They can weather the storm more easily.
Diversification, inventory management, any other ways they're coping?
Closer collaboration with suppliers.
Collaboration.
They're sharing information about production plans, forecasts.
So suppliers can anticipate needs.
and adjust their production accordingly.
It's all about communication, transparency, working together for a more resilient supply chain.
Exactly. Less susceptible to sudden disruptions.
Smart strategies. It's encouraging to see the industry taking proactive steps.
It's a necessity, really. Demand is only going to increase as the world electrifies, decarbonizes.
We need to be ready. Speaking of decarbonization, let's talk about the rise of renewable energy. Solar, wind, hydro.
Oh, absolutely.
They're playing an increasingly important role. And this shift is having a profound impact on the transformer industry.
It is.
In what way? How is it impacting design functionality?
Well, for one thing, it's creating demand for new types of transformer.
New types.
Traditional transformers are designed for a centralized grid.
Right, where electricity flows one way, from power plants to consumers.
Exactly. But renewable energy sources are often distributed, meaning they're located closer to where the electricity is actually used.
So we need transformers that can handle that two-way flow.
That's right. Transformers that can adapt to that decentralized model.
Transformers that can handle the fluctuation.
Yes, the fluctuations in power generation.
Because of the weather.
Exactly. Depending on the weather, the output can change.
So a new breed of transformers. More agile, more responsive.
Exactly. They need to handle that unpredictable nature of renewables. And we're seeing innovation with smart transformers.
Smart transformers.
That can communicate with the grid, optimize energy flows, even store energy.
They sound amazing. But what about the challenges of integrating these new transformers into the existing grid? Are there compatibility issues?
Well, one challenge is interoperability. We need to make sure those new transformers can communicate effectively with the existing infrastructure, which, can be a mix of old and new.
It's like trying to get different generations of computers to talk to each other.
Exactly. A common language, a common protocol for seamless communication.
Yeah.
We can't have a fragmented grid where things can't talk to each other.
That makes sense. What other challenges come with integrating renewables into the grid?
Well, grid stability. Renewables can be intermittent.
Intermittent.
Meaning their output can fluctuate.
Right, depending on the weather.
It can be tough for grid operators who need to ensure a consistent, reliable supply.
So how do transformers address this? How do they help ensure that stability when dealing with those fluctuations?
Those smart transformers can play a key role.
A key role.
They can smooth out those fluctuations, help integrate energy storage systems.
Energy storage.
That can store excess energy and release it when demand is high.
Goes like a buffer system to ensure a steady flow even when generation is fluctuating.
Exactly. And transformers are vital for this. They're becoming more than just voltage converters, evolving into intelligent grid managers.
It's incredible how they're evolving to meet these challenges.
It really is. And the innovation is accelerating.
New technologies, new applications.
Emerging all the time.
Speaking of innovation, artificial intelligence. AI is infiltrating everything, it seems.
It is.
And the transformer industry is no exception.
It's making a big impact, optimizing design, improving efficiency.
Predicting failures.
Even automating maintenance.
Wow. Let's break that down. How's AI optimizing design? Changing the way engineers approach it?
Well, one way is using machine learning.
Machine learning.
These algorithms can analyze huge amounts of data.
Data about?
Performance, materials, manufacturing processes, to find patterns, insights that humans might miss.
So like a super smart assistant.
Exactly. Helping engineers design better transformers.
More efficient, more reliable, with a longer lifespan.
Precisely.
Impressive. What about improving efficiency? Squeezing more performance.
AI can monitor transformer performance in real time.
Real time.
And make adjustments to optimize efficiency, like adjusting cooling fan speed or the tap changer position.
To minimize losses.
Exactly, like a virtual energy manager. Tweaking, optimizing.
Squeezing every last bit of efficiency out.
Exactly, translating to cost savings, reduced environmental impact.
Amazing. What about predicting failures? Getting a glimpse into the future.
AI algorithms can analyze data
from
sensors, other monitoring systems, to detect subtle changes that might indicate a problem.
So like a crystal ball.
Kind of.
A heads up before something goes wrong.
By detecting those early signs, utilities can be proactive,
Prevent failures before they happen.
address small issues before they escalate, saving time, money, and potential disruptions.
That's huge. And how about automating maintenance?
Oh, AI-powered robots
Robots.
can do routine maintenance, cleaning, inspection, even repairs.
Tiny robotic technicians.
Exactly. Freeing up human technicians for complex tasks. And improving safety, by the way.
Safety.
Fewer humans working in those hazardous environments.
AI really seems poised to revolutionize the industry.
It really does, changing the way we design, operate, and maintain these vital devices.
It's an exciting time to be following all this. We're on the cusp of a major transformation.
I agree. It's amazing how technology is transforming energy, and transformers are at the heart of it.
Speaking of transformation, I want to come back to sustainable materials.
Yeah.
We talk about biodegradable fluids, but any other eco-friendly innovations on the horizon? What other solutions are being explored?
Absolutely. Lots of research into new materials, new processes to reduce environmental impact, the whole life cycle,
That's great. So what are some of the most promising developments? What's capturing everyone's attention?
One area is new core materials.
Encore.
The heart of the transformer. It's what creates the magnetic field.
Right, allowing electricity to flow between the windings.
Exactly. Traditionally, they've been made from steel, which
Wow.
takes a lot of energy to produce.
Contributing to emissions.
Right. So researchers are looking at amorphous metals.
Amorphous metals?
Metals with a disordered atomic structure.
Sounds exotic.
They have very low energy losses.
So more efficient transformers.
Significantly more efficient. Less energy wasted, lower environmental impact.
And more efficient overall.
And they're strong, durable, longer lifespan for the transformer.
A double win for sustainability.
Exactly.
Are they being used yet?
They are, but they're still expensive, so it's mostly niche applications right now.
Waiting for the technology to mature, for costs to come down.
Exactly. But they have the potential to really reduce the environmental impact, a real game changer.
What other eco-friendly innovations are we looking at? What else is ripe for sustainable solutions?
Insulation materials.
Insulation.
The traditional materials, mineral oil, paper,
Right.
they're often from fossil fuels.
With a big environmental impact.
Exactly. Extraction, potential spills, leaks.
Researchers are looking for alternatives.
Alternatives that are high-performing and environmentally friendly.
So what are they exploring?
Bio-based materials like plant oils, cellulose fibers.
Nature's building blocks?
You could say that. High-performing and often biodegradable, reducing waste, minimizing that environmental impact.
Fantastic. Any other innovations in insulation? Anything else showing promise? Nanomaterials.
They're engineered at the atomic level, incredibly small,
With unique properties.
incredibly strong, lightweight, heat-resistant,
Leading to smaller, lighter, more efficient transformers.
and potentially more durable, extending lifespan, improving resistance to degradation.
They sound like a real game changer for the industry.
They have the potential. The research is moving fast, a lot of potential for breakthroughs.
It's encouraging to see this focus on sustainability,
It's a top priority.
not just altruism.
It's good business, too. Consumers, regulators, everyone's focusing on sustainability.
Companies need to show their commitment.
Absolutely. It's a competitive advantage.
It's not just about performance and cost anymore.
You need to consider the environmental impact.
Finding that balance between economic viability and responsibility.
Exactly. And the transformer industry is leading the way, showing how to adapt, to evolve.
Well, we've covered a lot in this deep dive.
We have.
The trends, the challenges, the opportunities. From renewables to AI, sustainability, the transformer as a platform.
It's been a journey. I never thought I'd be so fascinated by transformers.
There are more than meets the eye, that's for sure.
Absolutely.
I'm leaving with a new appreciation for their complexity, their importance.
They're essential, those unsung heroes.
The unsung heroes powering everything.
Homes, businesses, communities.
And as the world electrifies, decarbonizes.
They're only going to become more important.
Exactly. I'm excited to see what the future holds. I think we're on the verge of some really transformative innovations.
We are. We've only just begun to explore their potential.
And the coming years will be full of exciting developments.
Definitely.
Well, thanks for joining us on this journey of discovery. We hope you found it informative and engaging.
It's been a pleasure sharing these insights with you.
And we encourage you to stay curious, keep exploring the world of transformers.
There's always something new to learn.
And we're confident that this industry will continue to play a vital role in shaping our energy future.
Absolutely. Going through all this material, one thing that struck me is the sheer scale of it all.
It's massive, isn't it?
It's easy to focus on the technical details, but it's mind-boggling when you think about all those transformers out there.
Powering our world silently.
Each one representing a complex ecosystem. Materials, designs, manufacturing, maintenance.
The whole world.
Like a microcosm of the energy industry itself. Even the seemingly simple parts of our infrastructure are so intricate.
And constantly evolving, too. Technology, economics, environmental concerns, it all plays a part.
It really does.
Speaking of environmental concerns, I want to dig a bit deeper into the impact of transformers. We talked about biodegradable fluids, recycled materials, but are there other ways the industry is working to reduce its footprint?
Oh, definitely. One area that's getting a lot of attention is reducing greenhouse gas emissions.
From production and operation.
Oh, both,
Actually,
actually.
makes sense. Transformers are energy intensive. Minimizing those emissions is key for those global climate goals.
Absolutely. And there are a few strategies being used. One is improving energy efficiency, like we talked about earlier.
Right. Less energy lost during operation, smaller overall impact.
Exactly. Another approach is using cleaner energy sources to power the manufacturing plants themselves.
So, solar, wind power.
And some are exploring that. It's like using clean energy to create transformers that enable a cleaner energy future.
A virtuous cycle.
Exactly. And another focus is reducing hazardous materials in production.
Hazardous materials.
Some traditional components, bushings, insulation,
Right.
they contain substances that can harm the environment.
If not properly managed.
Exactly, at the end of the transformer's life. So the industry is looking for safer alternatives.
Alternatives that are high performing but also environmentally friendly. So, bio-based materials, recycled materials.
Nanomaterials even. We touched on those earlier.
It sounds like the industry is taking its environmental responsibility seriously.
It is. And it's not just about being altruistic.
It's good business.
Exactly. Consumers, regulators, everyone's looking at sustainability. Companies that show their commitment.
They have an advantage.
Absolutely. It's not just about performance and cost anymore.
It's about finding that balance.
Between viability and responsibility. And the transformer industry is leading the way.
It's a great example of how an industry can adapt. Well, we've covered a lot in this deep dive.
We have.
The trends, challenges, opportunities shaping the future of transformer technology. Renewables, AI, sustainability, the transformer as a platform.
It's been quite a journey. I never thought I'd be so captivated by transformers.
They're more than meets the eye.
That's for sure.
I'm leaving with a new appreciation for them. Their complexity, their importance.
And they're the unsung heroes
of our modern world, absolutely. And as we electrify, decarbonize,
their importance only grows.
it's exciting to think about what the future holds.
It is.
We're just at the beginning of some transformative innovations.
We've only just scratched the surface.
The coming years will be fascinating.
I can't wait to see what unfolds.
To our listeners, thanks for joining us on this deep dive. We hope you found it as informative and engaging as we have.
It's been a pleasure sharing these insights.
Stay curious, keep exploring. There's always something new to discover.
Always.
And we're confident that the transformer industry will continue to shape our energy future. Until next time, stay charged up.